Starting the stream. So where do I want to start? Program web page. So this is the website for this class. It'll have everything except for the readings that are copyright protected that I don't feel capable of posting publicly. As you will see on Tuesday's class, I've updated it with a link to the YouTube video that goes with it. So you can click that and watch it. I'm working on getting official captions on those, but for now, the Google captions are in place as well if I start speaking too quickly or otherwise need some of that. I have also made active the homework portal. So this is the play along with me portion of the program. If you don't already have it open, please open the website for this class. And we can all earn 3 points extra credit together to try out the system and make sure that it works. How's that sound?
That's great.
Yeah. 3 points extra credit / free late homework. However you want to think about it. That's my my offer here. It's a good deal, as my son would say. All right, so when you click on the homework portal, a new page should show up that looks like this. This around. There we go. It wants your last name. It is not case sensitive, but it is exact as how it appears in Maui. So that means if you have 2 last names separated by a space, put the space in. If you use a hyphen to separate names, that kind of thing as well. I have a whole bunch of dummy logins that I use to test things, so I'm going to log in with one of those just to demo for you. The 8-digit ID is your Iowa University ID. I don't have mine memorized. It's on my little card. So hopefully you have that with you or otherwise somewhere on your person, and you can plug that in, hit enter, and you'll see a page that looks like this. So this is the landing page. It will have each of the homeworks as they're available. It will have your current point totals of various kinds. So after a homework closes, I have to go through and manually download the database, check it for problems and that kind of thing, and then update the points. But you can see how many you have out of how many possible for homeworks, for quiz, formative assessments, as well as for bonuses. So you should know where you stand at all times. We have homework 0 here as one of the options. So before we click on this, did anyone have problems getting in? Okay. Can you send me an email with what you think your last name is, and I'll check it against mine? Because that may be, that's probably 99% of the problems there is crossing the names. This will take a good 5 seconds to fill out, so if we can't do it in class, then you'll have plenty of time to do it before it is due. So this is what they're going to look like. Except for this one, all of the others will have individual specific data files that will be available for download up here in this section, as well as syntax starter files. So what that means is that I'm going to give you the code that you would copy and paste into either SAS or Stata that would allow you to import the data set. It labels the variables so that you know what they're called and what they mean. And then that way you can focus on just getting the stats part right and not having to fight with the program with respect to the data. From there, we have 2 kinds of questions, and they will be interwoven into sections like this. So this example just has 2 sections, but one of them is computational. So the answers are all numbers. They must be entered to the nearest, whatever the precision is for an assignment to be correct. It's usually 0.01, so that means you need to keep track of at least 2 numbers after the decimal for it to be correct. In this case, we don't need to worry about that because these are all whole numbers. So let's play along. How many regular homeworks are planned for this semester?
5.
Oh, we gotta vote for 5, we gotta vote for 6. It's in the syllabus. Da, da, da. Well, let's try 5, since that's the lower one. So I'm gonna hit 5 and I'm gonna hit enter. Nope. How about we try 6? Not 56, that would just be inhumane. 6. Ta-da! How many points are these worth? 3? 3 for being late. How many points total can you accumulate towards what's supposed to be 100 points? It's 86, yes. Oddly specific, I know, but I like to be precise. How many of these points will you lose if you complete your homework even a minute late? 3. And yes, yeah. It's the system checks it against the time and date, so I don't have any control over that. But how many points extra credit is homework 0 worth? 3. Okay, so 4 for 4 so far. Then we have one type of results question. Now these are the kind that you don't get to see if you are correct or not until after the homework is submitted. But we can go through this together. So your instructor is me, Lisa. It's not Lessa or Lisa, by the way. Those are common other choices for my name, but it's just regular Lisa, just spelled phonetically. That's what I tell people. The story behind that, in case you care, is that my mom told me when I was born that I looked like a Lisa, but not the regular kind. There may have been some drugs involved, I don't know. My mom is not normally a spontaneous, creative person, so we have our doubts as to whether that story is legit, but that's what I tell people. Her office, meaning me, is located in...
356 South LC.
Yeah, it's south, which is the default in these buildings. If it just gives you a number, it means south. If it gives you a number with north, it means north. Very confusing. Although my office hours will be held. Any votes? Chipotle. You know, I love me some Chipotle, but it's kind of loud in there. They've sort of discouraged lingering with really loud noise and the most uncomfortable seats known to man. Another nice alternative would be at the Come and Go, because depending on what time of day, you can purchase your coffee, your soda, or your beer there. You know, it's very flexible that way. On the lawn would be lovely if we lived anywhere but Iowa, so probably not that choice. So I'm going to say in or around this room. Now, I say or around because I may be kicked out of here with no notice for office hours. If that happens, you will find me sitting out here on one of these tables because there's lots of computers out here that people can use, and that way I can still circulate and help people. There's both Macs and PCs out there, by the way. My office hours... Sorry about that.
Tuesday and Thursdays.
Yeah. Yes, and if no one is at office hours, which tends to happen if there's not currently a homework due.
You're sitting in the empty class.
Sitting in the empty class, I'll sit there for like a half hour, and then I'll decide that no one needs me, and I'll go back to my office and sit there. So if you come to office hours later and no one's here, check my office. I will have head back there. Yeah. All right. Next section, how many points from participating in out-of-class formative assessments count towards your grade? It was 86 for homework.
14.
Yeah, 14. And by the way, if it happens that I need to juggle the schedule such that we have to drop a homework or a formative assessment, I will keep the points that you've accumulated the same and just make a new total. So for instance, one of my classes last semester, I ended up with 86 points total. So it's still your percentage grade out of whatever points have been possible. But yes, 14. How many days does this class meet? 2. Yes, and so I know that's a source of contention for some folks because graduate classes only meet once a week. But I don't know about you, but after maybe an hour, my head is full when it comes to this stuff. So being able to come and be fresh a couple times a week, I think will make it a little bit easier on all of us. And for how many class periods are we currently scheduled to meet? Only by Zoom. Well, let's call that Zoom. Zoom, yeah, it's a new platform. You haven't heard of it? Yeah, it's 2 right now, but I will let you know if we actually have to do that. It depends on how many people have been set up for comprehensive exams. Last but not least, this class will use SAS, which is currently available for free, anywhere or only on campus.
Anywhere.
SAS is the anywhere one. This class will also use Stata, which is available for free. This one is only on campus, but what campus actually means, I learned yesterday, means when you are connected to EduRoam. So if you are someplace that is not Iowa City's campus, but it's still a campus place, and they have EduRoam, it counts as on campus. So that may help some of you who are commuting from other places. And then last but not least, this class will be a cakewalk, a nightmare, or a challenging but in a good way.
Challenging, but in a good way.
Ah, how did you see that one coming? That's my goal for you. So you'll see down here, after all of the computational questions are correct, it will let you know that. You can hit check and save your answers, and that means that any of the choices that you've made for these drop-downs will be saved. You can abandon the homework and come back and finish it later, and what you have done will be there. So any computational question you've already gotten correct will stay there and it will stay green. Any that are incorrect will just be blank again, so you can try it over. And all of your answers will stay so that you can not have to re-check the boxes. So it may look like I'm done, but I'm not. There's one more step to this. So before I show you that, are there any questions or problems so far? No. All right. So I have this button here called Submit Final Answers. But that's just the first step, because I want to make sure you don't hit it accidentally. So note what happens after you hit that button. The drop-down menus go away, and it just has your choices. So that may make it easier for you to just read through and make sure that it makes sense without having the boxes interfere. Everything is black right now in terms of that because it hasn't been graded. After you've gone through and checked everything, you're happy with it, you enter your password, which is your Iowa 8-digit ID, to submit your final answers. 1, 2, 3, 4, 5, 6, 7, 8. There's mine. And you can hit Submit Final Answers. If you look at this page and realize that you've made a mistake and you want to go back, there's a button to do that instead. So I'm going to hit Submit Final Answers. And at the bottom, it will confirm that your answers have been submitted and let you know when you can see how you did. Mine, since this is a dummy login, is set so that I can see my scores right now. Yours will be available after next Monday night. But let me show you what it looks like after you submit. So after you've submitted for real, rather than this button saying begin or continue, it will say view submitted answers. If it's after the deadline, the submitted answers will look like this, where anything that you got right will be in green. If you got it wrong, that will be in red, followed by the right answer in green. If you couldn't figure out one of the computational questions, the right answer will appear in green next to your last wrong answer in red. I would recommend that you save these things. Just either print the page, save it as a PDF, something like that. That way, in case of some sort of catastrophe that's out of my control, you know what your answers were, and if need be, I can manually reconstruct them. No joke, this actually happened last semester, where the website where this is located, it's called smarterasp.net, got hacked. And the people wanted to hold all of our databases hostage to get Bitcoin or whatever hackers want. They fixed it within like a day or two, but it gave me a panic for a moment. So just in case, right? Just in case. So this is the bulk of what we're going to be doing in terms of giving you an opportunity to practice this material, interact with the software to get the answers, and then be able to practice interpreting the results. What do you think? Good? Okay. When you're working through these questions, if you can't get an answer right, it is perfectly fine, actually a great idea, to send me a screenshot of like what does the answer that you tried, and tell me why you think it's right, and I can help you navigate towards the right answer or check it to make sure that there's not an error. So letting me know where you are on these things is going to be helpful. In terms of strategy, so each of these assignments is going to be worth somewhere between, I want to say, like 8 and 16 points, depending on how complex they are. So if you think about the cost of a 3-point penalty for being late versus a small fraction of 1 point for missing 1 question or 2 questions, it's probably better to go ahead and submit it on time, knowing that you might have missed 1 or 2 questions because you'll be missing like a 0.05 of a point per answer. After the fact, you can always go back and try to reconstruct what it would have been, and I'm happy to help you with that practice. So, okay. questions on this? Okay, so if you weren't able to log in for whatever reason, please email me immediately so I can check out why and solve the problem for you. I will let you know via email and announce in class whenever these things are open, at least a week in advance, preferably a week and a half or two, but I try to time it to make sure that I know that we're going to be able to cover the things ahead of time. So you won't have your first homework due until week 4 of class, which is Monday night, 2nd of February, or February 10th, I should say. All right. Everyone's quiet. Do we need more coffee?
Yeah.
Yes. Yeah, I wish I could help. All right. What else did I post here? Okay, I also posted this. So I made this handout yesterday. It's based on some of the difficulties that I encountered last semester with the same class and trying to get up and running with the virtual desktop. It turns out there are a number of preliminary steps that you have to complete to be able to get your device ready to do this. And so I tried to provide links to places that discuss how to do those things, but they include getting the virtual private network software, Iowa Anywhere or something like that. It's something very close to that running on the background. They recently converted this over to two-factor authentication, which took me a minute to figure that out, so I have instructions here on how you can hack that. You have to be connected to EduRoam on campus, not the guest network. And connecting to that is a combination of your Hawk ID and an email-like extension, but it's not your email address, because that would be too straightforward. There is a magical H drive that if you log into a campus computer is automatically assigned to you. You may already be using it. Last semester, people who used that to store their homework assignments had far fewer problems trying to figure out where they were and make sure that they could get those files back again when needed. So that would be what I recommend. It is, of course, possible to store your homework anywhere on your computer and have it find it, but H drive seems to be a magical place. So I have the first set of files that we'll be working with in class to try and figure out how to get inside the system and get SAS and Stata up and running here. Then once you are inside the virtual desktop, you will see windows that look like this. So this is what SAS is going to look like. This is what Stata is going to look like. And it's as if you are sitting right there and the program is open like a regular program on your computer. With one important exception. I will warn you about this ahead of time. If you don't attend to it within like 10 minutes, it thinks you're done and logs you out. It does not save your work before it does that. So just as if you have a laptop that's on its last legs and you hit Control-S about every 30 seconds to make sure you don't lose anything, get in the habit of doing that just in case somehow you lose connection to the network and it takes your work away. Let's see, so there's more instructions on how to get this started. This is the part that I hope we'll be able to do in class and be able to actually run some things together. Because I know that is a non-trivial thing to get it working for the first time. After you conquer it once, it'll be a little easier. And then if for whatever reason the virtual desktop is just not going to work for you because you need to use data from off campus, it's too annoying or whatever, you can throw money at the problem. So those of you who want to use Stata off campus and are willing to part with $48 to be able to do so, here's where to buy it. You do not have to do that, but sometimes it's easier just to do that than to fight the system. A few people did that last semester. SAS, as far as I know, is prohibitively expensive to buy a license, even as a student or even as a trial. But there is another way to access SAS for free, which is called University Edition. This is what I used at my previous universities to be able to have people do their homework. It's compatible with both Windows and Mac operating systems, and it works through a virtual machine. So it's not quite the same as virtual desktop, but it's based on the same sorts of principles. So I can also help you with that if that's a route that you want to go. So the objective then is for you at some point on your own to try to get through as many of these steps as possible with the machine that you want to use. If you want to come to office hours and hang out and have me help you, that would be lovely. I get bored all by myself, of course. If you have questions as you're working on this stuff, please let me know. Depending on the speed of your internet connection, some of these steps may take longer than others, which is why we're not going to try and do all of them in class, which I learned last time does not work. So, trying to learn from my mistakes. All right. How are we doing? Nodding? Are we back to life? Maybe? Maybe? All right, Zoomers, do you have any questions? Or to chat. We have some questions. Can we show me the screen or no? Oh, goodness. My bad. Yeah, I can totally show you the screen, and I should have done that already. My bad. Okay. Does that help? Hopefully it will. All right. I meant to do that. I really did. Oh, chat. They say yes. Victory is mine. Okay. Now we're back together again. So let's pick up where we left off last time. How about that? Last time was a big word salad. Because, like any other discipline, quantitative methods has its own language. So we talked about this class, talked about software, talked a little bit about vocabulary. We talked about sampling. So one of the key ideas that I was trying to illustrate is this independent versus dependent samples. Do you guys remember that? Give me an example of when somebody would have an independent sample. This is the audience participation portion of the program.
Well, my notes say that in an independent sample, the people are unrelated, but I don't know what I meant by that.
Well, that is correct. It's easier probably to think of when that would not be true. So this is the College of Education, right? Mm-hmm. Independent samples are pretty rare because we have students who are grouped nested. Nested means grouped within teachers and classrooms. They may also be crossed with teachers and classrooms, meaning that they share, they move around. Teachers are nested within schools. Schools are nested within districts. So the idea that people from the same whatever are going to be more alike than people from different whatevers, that's dependence, or non-independence, as it is sometimes called. So if you have a sample that is not drawn from multiple units, like if you have all the children in one classroom, that's it. In theory, that could be an independent sample. You would likely have measured characteristics of the children that might make some of them more related than others, such as what reading group they're in or what math unit they're in or something like that. If you were to put those characteristics into the model, then the students would be independent conditionally, meaning after factoring in these reasons, they're independent. Why that matters is that the models that we're starting with this semester, and this is all that we have time to cover this semester, are for independent samples. Those are the simplest cases of the models. Everything that you're learning in here, you will then add other stuff to be able to analyze data from dependent samples. But starting with dependent is a recipe for disaster. That takes years and years and years because those models become increasingly complex as the sources of dependency. Same thing with repeated measures. So if you measure the same person over time, their observations are dependent, meaning they're related, because they came from the same person. So those types of models would be known as multivariate models, meaning you would have to try to predict all of a person's outcomes simultaneously, rather than being able to predict just one outcome at a time. Okay, does that help? Okay. So yes, that's the big thing is trying to get in your head whether or not what we're learning is going to be sufficient for your needs. And odds are good, life is more complicated than that. I just want to put that out there to begin with. We talked about predictors and outcomes. Remember those words? What's the difference? Cheers.
So the predictor you classified as an explainer
Mhm.
and labeled X.
Yep.
And the outcome is what to be explained and you labeled it Y.
Yep. And then I like the you labeled it because that's really important. Notation is always person specific. I am trying to keep my notation internally consistent so I don't confuse you, but you may find other textbooks that call outcomes X's. And that's their right. But I'm trying not to be mean. So outcomes are Y's and predictors are X's in the notation. So predictors are either things that you've manipulated, like in an experiment, you assign people to one group or another, or things that you've measured, but you're measuring them because you think that they are going to influence, in a theoretical sense, something else. The something else that it's influencing is the outcome. That's something that you've measured. If it's something you've manipulated, that's cheating. Come on, that was funny. We really do need some coffee, don't we? Do we need to like get out of our chairs and like do some calisthenics, something like that? Would that help? I'm actually dead serious. Would that help?
I'm fine.
No, you're fine? I know. There's this whole trend towards, sitting is bad for you and you should stand and stuff. And I'm standing right now just because I sort of like, this is my like presentation mode that I'm in, right? I can't sit and teach, but I don't have a standing desk. I never will. Do you know why?
Why?
Because I went to school and got a PhD so I would earn the right to sit the hell down. I had too many jobs where I was on my feet all day wearing a name tag, right? That covers a lot of ground right there. I waited tables. Not the worst job even, which is saying something, but my freshman year of college, I tucked shoelaces into boxes of shoes at Walmart for $5.25 an hour.
Lord.
I know, that was, and I barely made ends meet as, working 30 hours a week. And I decided, no, I was already in college, but that solidified my motivation. So yeah, I'm sitting the hell down. Otherwise, if I'm not standing here. So you know what? Just stay there, right? You've earned it, right? You're good. You don't want to get up, right? He's like, yeah, I told you that. That's fine. I understand that. I just got to try to keep the energy up, right? Because I'm lost, I've given up, and I'm bored, move on. Those faces are the same from my perspective, right? So it's like, if you're smiling, at least maybe then you're with me, and then I can like see which one it is back. But there's that I'm going to keep trying to do this, right? I love teaching in person. I can't imagine doing it online where I don't get to see all of you and your reactions. That's just, what's the fun in that? Yeah, there's none. So yeah, we started talking about all kinds of words. I want to talk about variables. I think that's a good place to start. This is slide 20 of lecture 0. So what's a variable, first off? Variable versus constant would be the relevant distinction. And it's okay to look in your notes, that's what they're for.
Constant is something that's the same for everybody, and a variable is something that changes.
Yep, constant is the same for everybody, and a variable is something that changes. It seems obvious which one would be, but it's not always. To give you an example, I recently looked at a data set where it was qualitative coding of behaviors. So a 1 if a teacher did this, a 2 if they were observed doing this, etc. And so they measured all of these different behaviors and the frequency with which they happened. And it turned out that in the sample, the teachers did, all of them did one of the behaviors. Like it was supposed to be whether or not a teacher did this as a predictor, but everyone did it. So it started out as a variable in theory, but in practice, it was a constant. And what does that mean with respect to whether or not that piece of information can be used? It means game over, right? If everybody has the same value, that can't possibly be why something different happened as a function of that, right? Constants don't predict anything. Variables, however, they can be predictors or outcomes. So this taxonomy that I'm starting with on page 20 is I'm going to say it irregardless, because I really want to say that, of whether it's a predictor or outcome. I know it's not a word, but it's like very regardless is not a word either. So I'm going to go with irregardless. There's a reason I'm in quant methods as opposed to literature. All right, so traditionally speaking, this taxonomy maps onto what some would call levels of measurement. If you've had previous statistics or research methods courses, I'm guessing you would have been taught this. So it's related to this, but not entirely. My perspective on it is how you would deal with these variables in a model. Like, how do the categories map onto that? That's what I'm going for. There's two main kinds of variables in terms of like the biggest distinction: categorical or quantitative. So categorical are variables that may be stored represented in a data set with numbers, like number 1, number 2, number 3, but the numbers are not numbers, they're labels. So enter 1 if you have a cat, enter 2 if you have a dog, enter 3 if you have a fish, right? You could have assigned any number to those categories and it wouldn't matter. The numbers are inconsequential. It's the categories that matter. And from that perspective, then there's 3 kinds of categories. There's binary, yes or no for an item type for a quiz, for instance, dead or alive, pregnant or not. As we all know, there's not anything, you can't be a little bit pregnant. Doesn't work like that. Nominal is when you have categories, but there's no obvious order. So favorite type of pet. Now, we might internally think, well, there's a hierarchy because you're either a dog person or a cat person, and people identify that way. But we wouldn't agree on the hierarchy. Favorite type of ice cream, for instance. The only wrong answer is mint chocolate. Mint and chocolate together is just wrong. Yeah, I don't brush my teeth with a chocolate bar for a reason. But everything else would be fair game. Ordinal is a very common type, especially in surveys, where the numbers kind of look like numbers, but not really. So you may have strongly disagree, or agree, or strongly agree. And you may have to circle a 1 if you strongly disagree, or a 2, or a 3, or a 4. And people are tempted to treat them like numbers, but they're not. They're ordinal. They're ordered categories. The numbers that are assigned to them are inconsequential. I could have had you circle 1, 20, 300, or 4,000, and that would be equally correct, because those same numbers obey the ordering. The distances between them cannot be thought of as equal or interval, as this coming next. So this concept of a categorical variable goes by a lot of names. It's sometimes called discrete, sometimes called qualitative as opposed to quantitative, not like in a qualitative research sense, but in a numbers or words sense. Grouping variable is another one. Factor variable is in a software sense, like the program R uses that language, and also a class variable. If you read the SAS manual, you will see it called that. That just means a classification, meaning that it's a grouping thing. Okay, with me? Okay. Other big umbrella kind, quantitative. Numbers are numbers. They are interval. The distances between them actually mean something. Quantitative variables then, in turn, have different types of features. One type of quantitative variable is quantitative, meaning that numbers are numbers, but it has boundaries. Natural boundaries are ones that are imposed because of the way that the variable is measured. So binomial is sort of the generic word that I use for this. It's the number of occurrences out of total possible. So for instance, in this class, you can earn somewhere between 0 points and 100 points. Guess which one I want you to have? 100. Yeah. That's my goal. I don't want a distribution. Actually, I can make a stats joke for you. A distribution where everything is one number for a constant is called a degenerate distribution. Mm. I know. They had a word for that. But that's the one I want. But the best you can possibly do is 100. If you are in a situation where you're scoring a test and each person has a different number of items for whatever reason, instead of going with number correct, you might want to convert to proportion correct or percent correct to be more fair. And it's still the same idea. It's bounded where you have the lowest you can possibly go is a known number, the highest you can possibly go is another known number. Back up. When you're trying to predict these type of outcomes, your model has to understand that it can't go below 0 and it can't go above 1. That's the trick. And there's models that are built for that we're not getting to in this class. It's the follow-up class. Likewise, count variables. Counts are quantitative variables that are only integers. Like you can't smoke a cigarette in half. Doesn't work that way. You can't dig a hole in a half. But in counts, they also have a feature that you can't have a count that's negative. You can do something nothing, but you can't do something less than nothing times or fewer than nothing times. So in this instance, there's one boundary on the 0 side, and whatever model would predict a count has to understand that you can't have a predicted count that goes lower than 0. Sorry, working on this thing. I have to hold my arm back so I don't get it. But there's no limit to the number on the positive side. So how many text messages did you send last month? Right? I have no idea. I would guess maybe 100 or 2. And they all sounded like this. I'm leaving, do you need anything from the store? Or, I'll be home in 5 minutes. It's like a series of do you need anything from the store or not? Text messages, that's my life. In contrast, my stepdaughter, who's 13, I would guess her number is up in the millions. There really is no boundary. It's positive infinity for the count variables. You're limited only by your imagination and tenacity and possibly thumb strength. Although I'm one of those old people who still does this. I never quite figured out the thumb thing. I can't get that. Just as an aside, count variables have 2 special types. One is for variables that have no zeros. That is called zero truncated. That can happen whenever, to be included in the data set, you have to have been part of the thing you're measuring. So let's say that you're predicting number of days for a hospital stay, and you get a secondary data set from a hospital. Well, in order to be in the data set, you have to have been in the hospital for at least 1 day. So there's no zeros. That in turn requires a special kind of model that understands that. More zeros than expected, which is known as zero inflated, also needs a model that understands that. These variables are actually really common as outcomes. I refer to them as if and how much. It's whenever you've mixed a kind variable with an amount variable. So for instance, if I had something like, severity of sexual abuse encountered, something like that. There may be a portion of the sample that scores a 0. They answered 0 to all the questions, and so people who haven't experienced anything like that is one type of person in your sample. And then there are people who unfortunately have experienced something to some degree. And so for those kind of people, amount is then relevant. So you can think about, even though it's one variable, it actually becomes 2 things. Whether or not you've experienced the phenomenon, and if you have, how much. There are models for that too. You can also use those types of variables as predictors, in which case you explicitly separate out those 2 parts to be able to look at what is the effect of being in a category versus the amount within the category that's the experiencer. So these are all quantitative variables. They may have to have special models that go with them to obey the boundaries. That's the key for that. And then last but not least, quantitative variables that are actually continuous. So continuous means 2 things. It means unbounded, meaning there's no theoretical lower or upper end that you can hit. And it means they can take non-integer values. These types of variables are basically non-existent. But don't let that stop you. We're going to use that type of variable, or assume that that type of variable works in most of the models I'm going to teach you. because it doesn't have to hold exactly, it just has to be plausible. The general linear models that are the focus this semester say that the outcome has to look like that after being predicted. Otherwise, you need a different type of model. And so the follow-up class to this one, the one that I'm actually teaching after this class and I plan to teach each spring, focuses on how to predict outcomes of all the other kinds I just mentioned. The ones that are not continuous and unbounded. More often, we take outcomes that are not continuous and unbounded and we pretend that they are. So for this type, I introduce the word continue-ish. Not exactly continuous, but close enough for government work, that kind of thing. So examples of this. There is literally a category known by this, ordinal treated as integral. Have you heard this phrase before? It's like, yeah, I know I'm cheating, but I'm going to go ahead with it. Have any of you worked with sum scores before? Like, you sum up the number of the responses on a test? Yeah, that happens all the time. That's this. So if I have a test of 10 items, let's say each item it ranged from 1 to 4. It's one of my strongly disagree, disagree, agree, strongly agree things, right? Those 4 labels we agree is ordinal, right? The difference between strongly disagree and disagree is not necessarily the same as the difference between disagree and agree and strongly agree. We agree in the ordering but not the relative distances. But somehow, if we take those 10 items that are each scored that way and we either sum them or create a mean, we call that continuous. It's not, but there's enough distinct values where it starts to approximate something that truly is. It does still have a lower bound for the minimum if you got all the same, the lowest value for all the items, and an upper bound if you had the highest one for all the items. Those are known as floor effects or ceiling effects, respectively. Interval but still continuous. There are other variables that you may come across that are actually continuous, but they have some sort of boundary to them, which keeps it from being truly continuous. Response time, for instance. That's a common measure of cognitive ability or processing speed. But what's the fastest that you can possibly do something in? Well, 0 sort of in theory, right? But there's some lower bound where if you respond more quickly than that, people don't believe that you're actually doing the thing that you're supposed to have been doing. So discounting responses below, say, 500 milliseconds or something like that. Heart rate is another variable that's truly continuous. It only depends on the quality of your measurement instrument, how precise you can be with that. And also, latent trait estimates fall into this category. So things like GRE scores or Roche scores. Have you heard of those? Standardized scores from instruments that are linked together so that the test can change as children age, that kind of thing. Vertically equated scores. Those I would call continue-ish because they're supposed to be continuous, but in practice, there may only be certain values that have floor and ceiling effects based on the types of items that have been given. So lots of intermediate categories. Big picture though, the variables that we're going to be working with are either categorical, where the numbers are labels, or some kind of quantitative where the numbers are actually numbers. That's the major distinction that is important to pay attention to. There's also ratio. To be honest, my husband insisted I put this in when I told him about this class. He works here too, so you'll hear stories about him. I've never actually seen a ratio variable in my life. I'll just put it that way. In the social sciences, we don't get this level of precision, but it is there. So if you have a ruler, for instance, you can say something is twice as long, and that phrase actually means something. If you have a measure, say, of IQ, and you get a 50 versus 100, they're not twice as smart. Like, it doesn't work that way. So ratio is another kind of quantitative variable that we aspire to, and we never actually get there. All right, so practicing then. So I gave you these same questions last time with respect to which variables are predictors or outcomes. Now we can practice labeling them to the best of our ability. So to what extent does positive feedback improve performance, speed, and accuracy more than neutral feedback? You had told me that feedback, I'll abbreviate it positive neg, was a predictor. What kind of variable do you think that is? I'll take binary, and I'll take what you were going to say too.
Categorical.
Categorical. So sort of categorical is the bigger term, binary is specific. Put binary within categorical, we'll call it that. Outcomes, we had speed,
And accuracy.
yeah, and accuracy. These are definitely quantitative. However, speed is going to be more continue-ish because it's going to be more unbounded, whereas accuracy,
Either yes or no, so.
if it's a rate, like percent
Oh.
correct,
Okay.
then what would it be? Starts with a B, not binary.
Binomial.
Yeah, I'm calling that binomial.
Okay.
Binomial is a count out of how many, but that converts to the same idea if you correct for the differences in the possible and just look at a rate. The key idea is that it's numbers, but they have boundaries. They can't go past certain points. Academic growth in elementary school was the outcome. More frequent reading to children in preschool. So frequency of reading. I'm putting a question mark there. Can you tell from this wording what it's likely to be?
Count.
It could be a count. It depends on how the researcher has phrased the question, right?
Right.
Because you could have how often do you read to your child as a blank answer, or you could have like once a day, more than once a day, once a week, once a month. If they do the latter, it's ordinal. Even though it's sort of related to time, the distances between. I'm going to say likely ordinal on this one. The other one was time. That one is continue-ish, probably, because it's numbers are numbers. Special cases would be what happens if not everybody has the same occasions, in which case you can have intermediate values. There are models to handle that as well. Outcomes, academic something, right? Because growth is not a thing, it's growth of something, but we don't know what that is, so. How effective is teacher training for creating higher rates of positive feedback? Teacher training, not enough information there. I'd probably guess categorical. It sounds to me like it's either the presence or absence of it, but it could be kinds or degrees. Stop that. I'm going to have to get better at that. Outcomes, rates of positive feedback. I'm calling that one binomial because it's rate. That means there is a 0 and a 100 that's going to be present in that. So hopefully going through this gives you a sense of when you can create more informative questions. Parentheticals that delineate what the kinds are or the amounts can help someone keep their head around how are you actually operationalizing this variable and how are you measuring it.
Wait, how big it was.
Okay, slide it to your back.
Did they ask for a box?
The actual box. This? Okay, we'll try that. Okay, may have to be my belt. Okay, or I may just have to carry it. We'll make that work. I'll work on it for next time. Back to the show. All right, I think given the time, we're probably just going to get through the rest of this and start lecture 1 next time, but that's okay with me. I'd rather go a little more slowly than rush through things and not do a good job. So how many of you have worked with some sort of quantitative methods or quantitative data before? Okay, a lot of people haven't. That's okay. There are some tips and tricks that I wanted to give you because no one ever really talks about this. They just assume that your data is like ready to go. And the process of getting it from nothing to ready to go is really challenging. To be honest, if I'm doing an analysis, 80% of the time is spent fighting with, checking, rearranging, or manipulating the data to be how it needs to be for me. And there are some things you can do to save yourself a lot of time. if you're in that situation of having to figure out how you want to store quantitative data in the first place. First off, spreadsheets are fine. Excel is your friend for data entry. There is no reason that you have to enter things into SPSS or Stata or anything else. Excel, you can use freeze panes, you can use things where it limits how many values you can put in, things like that. Excel is your friend. All major software packages can import Excel files, and that is exactly how your homework is going to come to you in data files. That way you can look at it yourself without having to be wedded to any particular program. In terms of data entry into someplace like Excel, you can put the name of your variables into the first row of the spreadsheet, and all programs have a capacity to understand that that is what you want to name the column in your data set. With one catch, the names that you use, if you want them to become column names in a data set, have to obey the standards of the data set. So that means do not use spaces. They will get converted to something else, underscores, dots, or otherwise. You cannot use special characters other than underscore. You cannot use dashes, for instance, and you can't start with a number. So if you know these things ahead of time when you're naming your columns, you can save yourself having to rename things. They all have to be unique names, of course, as well as another piece. Using only as many characters as necessary to keep it unique. That's key because it will drive you crazy later on otherwise. Because every variable name that you create, you're eventually going to have to type over and over and over again as you run models on it. And the longer your name is, the more typing you're going to have to do and the more error prone it is. Because Stata, SAS, and otherwise insist that you spell things right. And Stata, above that, is case sensitive. So if you sometimes capitalize things and sometimes don't, it will not understand what you're trying to get it to do. There is a way that I will show you to add better clarification as to what a variable means and where it came from with a label. A label is like a comment that is attached to the variable that you can have up to like 256 characters, I think, so that you can provide whatever level of complexity that you need to be able to know for good housekeeping where that thing came from. It's helpful if you have a series of items that all refer to one source, like you have a questionnaire and you have question 1, question 2, question 3. If you name them in a series like this, so if I have a measure of stress with a bunch of different items, the first item I would call stress 1, and then stress 2, stress 3, rather than words that refer to the items. The reason for this is the capacity for abbreviation. These programs allow you to abbreviate through some mechanism, like you can say stress 1 dash stress 50 later on, and it will understand that you mean all of them. If you name them item 1 about this, item 2 about that, there's no way that it can understand what the middle values are, and you'll have to refer to them all manually. So it will be helpful if you have this sort of convention where the number is at the end, because then it can interpolate what should come next. Okay, another thing about the spreadsheets, I know it might be tempting when you're entering data to do things like bolding or shading or color coding. Don't. It's helpful for you to look at it as a spreadsheet, but there's no easy way to tell SAS, hey, any number in red means this, any cell that has a green background means that. Like all of that information that you painstakingly make it look nice to you doesn't get translated. So if there's anything about a value that you need to somehow clarify, that should be another column next to it, where you can say it's a 1 if I mean this and a 0 if I mean that, or something like that. Also, categorical variables. Use numbers for them. That is my best recommendation. It is possible to create columns in a data set that are words. Those are what's known as string variables or text variables. They are very tricky to work with because each value that is supposed to be the same thing has to match exactly. No extra spaces at the beginning or the end, capital letters versus lowercase letters. So something like this, where I have control group, this is not the same thing. And if you have people hand entering this stuff, even the most vigilant RA or yourself is going to screw this up at some point. So don't do that to yourself. If control group is what you mean, that's 0, because typing a 0 is a lot easier than getting control group right every single time. You can then, in the program, add what's called a value label. That is also like another type of comment where you list the mapping of how the numbers correspond to the labels. That way, when you're looking at your output, the labels are what you see, not the arbitrary numeric values assigned to them. With one caveat, this is something that I learned the hard way fairly recently. When you assign value labels in some programs, it switches the internal ordering to be alphabetical. So for instance, if what I have is control group and alternative group, and that's coded 0, 1, when it spits out descriptives, it will start with alternative instead of control because alternative starts with an A. That will drive you crazy if you're used to looking at things in a certain order. So the way that I solve that is to put the number inside the label. So then they stay in the order in which I have intended them. You may be tempted to somehow have numbers in a column and then also add words here and there if you weren't sure what the number should be. Don't. That converts the whole column to be string variables or text. So even though it's a 0, it's read as text. In my humble opinion, you don't need missing data codes. So this is something that is software specific how you define them. But it works in the same way where there's a labeling system where, let's say, you put in a value for something that's missing. Minus 99 is a common example of this. The reason that it's minus is because that value is highly unlikely to happen in practice, but it could, right? And inside the software, you have to make sure you designate that anything is minus 99 is missing. So like in SPSS, there's a box for this. Other programs, there's a box for this. But when you go between programs, those instructions don't always translate. So what happens is that sometimes the minus 99s will stay, but the new program will think they're real. And that screws up everything. So here's the trick. If you have missing data, let it be blank. In your spreadsheet, let it be blank. Because then it shows up blank, and that's what it is. It's not there. If you need to track reasons for missingness, like I didn't give them that question versus they told me they weren't going to answer, things like that, which do matter, I would create a separate column for each variable that has types of missingness, where 0 means it's not missing, 1 means it's missing for this reason, 2 means it's missing for that reason, and it's a categorical variable. Keep it separate. Dependent data. So this is something that I've seen people spend way too much time on if they didn't know this in advance, and so I'm trying to help your cause here. I'm one of those people who I've made the mistakes that I talk about. My shining moment in graduate school is that I once spent 6 weeks doing something by hand in a spreadsheet that any program would have done in like 3 mouse clicks for me, had I known about the option. I had a PhD student at Kansas who spent her entire summer calculating sums across rows of a spreadsheet, and she had her son helping her, and that in turn is 1 line of code in a program to do it. So yeah, there's tricks that I'm trying to save you from, right? And this is one of them, how to handle dependent data. The easiest thing is that if you have data collected at multiple levels of sampling, each level of sampling goes in a separate spreadsheet. So let's say that I'm doing a longitudinal study of children across semesters in multiple classes. So that means that I have at least 3 levels of sampling. At the lowest level, I would have time-specific information. What day they were tested, how old they were at testing, what score they got that day, that kind of thing. That's one data set. And I would have an ID for which child it was, which occasion it was, and if it's a classroom or teacher thing, which teacher or classroom it was. At the classroom level, I may have classroom characteristics. That's a separate data set. If it's at the child level, I may have things like the child's date of birth, or parent information that I collected only once, that's another data set. It is real easy to merge those things back together again as needed. It's a lot harder to try and think about what the lowest level of sampling is and then paste all the values that would be constant down. If you merge correctly, that will happen for you. So if this is something that you know you're going to have to tackle, let me know and I'd be happy to give you some resources on how to do that. Yeah. So another thing while I'm on that topic, certain programs spit out separate spreadsheets or text files per participant. There's some qualitative data coding programs that do this. Things like, trying to think of it, Media Lab and ePrime and stuff where you're collecting like experiments. Do any of you work with things like that? No? Okay, well, count your lucky stars, first of all. But if you do, if you're ever in the situation where each person has a separate file of some kind and you need something that reads them all and gets them all together, that's like 4 lines of code. I can help you. So don't be shy if you ever are in a situation like that. So these are the sorts of tricks that make quantitative analysis a lot less painful. Okay, so wrapping this thing up then. End goal of the semester. What are we here for? We're trying to use general linear models. Those are models for independent observations that are supposed to be predicting quantitative outcomes to analyze data. So that's going to require a few prerequisite skills. First off, words and symbols. So this week has been a word salad. We'll start picking up letters, Greek letters to go with them, as well as different symbols, and decision rules by which to relate all of these things together. The first thing we have to do before we can predict anything, though, is describe what we have. So starting next week, univariate statistics, meaning pieces of information about a sample, one variable at a time. You know what these things are. Things like proportion in each category, mean, potentially variance. These are things that Excel can calculate for you, but the trick is getting SAS and Stata to do it for you instead. After that comes bivariate statistics, being able to describe associations between pairs of variables. And then we're ready to actually do some modeling. So to me, modeling is everything because it's how you actually answer the questions that you have about your research. It always comes down to a model. And so that's the skill set that I want to start teaching you. GLM, these specific types of models for independent samples on quantitative outcomes that are supposed to be continuous, that's only the beginning. There's all different kinds of models for all different kinds of data. The skills that you're learning now will enable you to be able to build, to be able to get those other types of data in the future. That's my goal for you. So research questions then. Each variable is either a predictor or an outcome. How do you know which is which? It depends on the question. One person's predictor is another person's outcome, especially in observational data where you just collected a whole bunch of information. It's not always easy to tell, but step one before you can figure out what to do with the data is what do you want to know? What is your question? Because answering the question then is a series of decision rules according to how you need to model it. The variables that are part of your question, though, first we have to figure out what kind of information we have. Are they categorical, where the numbers are labels? Are they quantitative? If they're quantitative, are they really continuous, or do I need to worry about boundaries or other special issues? And then last but not least, we talked about this last time, you will not hear the word cause come out of my face anymore this semester. We're just going to talk about related to, predicted, associated, all those sorts of words that do not make a judgment about what really came first, because those things have to happen by design, and that is a whole different set of classes. All right, black. There. How are we doing?
Good.
Good.
So if I let you go 5 minutes early, are you going to be upset with me?
No.
No?
I'm so distraught.
You'll be distraught? They'll give you time to get that coffee that you need to get through the rest of your day, right? Yeah, that's what's nice about having the gas station across the street. You can reload anything that you need. All right, any questions before we adjourn? Okay, then next week we'll start on lecture 1. Try to work on getting your laptops or desktops at home equipped to do stuff. Question?
Do we definitely not have are we not in class next Thursday for sure? Are we doing Zoom or
Next Thursday, is it that early already? I thought it was
is it 2 weeks?
2 weeks.
Oh,
The 6th is the day that we may not have class. It depends on whether or not this room gets taken over and if they can find another one for me. So Zoom is sort of like I know I can make this work if I need to. Whether or not we lose the room and whether there's another one available, I have to see in the meantime. They won't know if they kick me out until they know how many people are sitting for comprehensive exams. And apparently that isn't known yet. That's what happens.
Do you know when you would know?
As soon as Scott tells me. So hopefully by next week, I would think. So we'll figure it out. Others? Okay, go get your coffees. Have good weekends.
Thank you.
And I will see you on Tuesday. Thank you. All right, Zoomers, do you guys need anything? There's a chat. You're welcome, Melissa.
I wrote
All
one
right.
of those for 2 years for a student. I had a student who was deaf, and I had who walked